Hey everyone, today we'll be doing another lead code problem 102 binary tree level order traversal. This is a medium problem. Given the root of a binary tree, return the level order traversal of its node values from left to right and level by level. So we have given a binary tree 3, 9, 20 and 20 have its own nodes 15 and 7. 3, 9, 3, 9 and 20, 15, 7. So we have to return it in this form so that the very first node, which is our root, returns its own list, and the two its children nodes return their own list level by level, like they are on the same level, they have the same parent, you can say. And this children of 20 leaves of 20 will give us its own list 15 and 7. So we will be seeing and how this works. So first of all, we will check the base condition, and this specific problem can be done through BFS, but can only be done through BFS, I would say. So we have to use a queue, but there is another method in Python. You can use the list to do this problem also. So in this video, we will just be doing the queue method, and the other solution I'll post it in the future, maybe some time in the future. I don't know if I ever got the chance to do that, but yeah, let's get started. So if not root, if there is nothing to begin with, we will just return the empty list, and we will be making a queue because this is our queue solution. So we will collections dot dq dq and q is q dot append. We will give it our root, append root, and after doing this we will make our list in which we will be holding on all of the levels. So while q is still there, and we will make a level list for I in range of length of q. We will make a node variable, node which will pop like this. Pop left means you are getting the first variable. If you have seen the other traversals, we are using a stack in which we just take the last, whatever goes last comes first. In this, whatever goes first comes out, also first, whatever goes first comes out first, yes, like this. And now we will check if the node is not null. We will append it to our level, append node val, and after doing this we will check the left and right and append it to our queue, nodes left first and then right. Because this is a queue, we will always be getting the first element first. Whatever goes first come first, goes come first, yes. And yes, after doing this we will check if our level is still exist, our level is not empty. So we will append it to our result, appending it to our result, append level to result. Okay, that's done. And after doing all of this, we will just return result, and we are good to go, I think. So let me check if there are any errors, then I will explain what is going on here. So there are no errors. Okay, so let me draw the whole tree here. What was our tree? 3, 9, 20, 3, 9 and 20, and 20 has its own leaves, children's children. Okay, so we have our queue, and we have our level, and we have our result. Okay, so by default, like from starting from the very scratch, queue will have 3, and the level is empty. queue is not empty, we will enter the loop, and the level is not empty, and we can see the length of queue is 1 at the first point. The length of queue is 1, so this part of the code will run only one time. So we will just pop the queue out of the stack and put it in our node variable. Let me make a node variable which is now holding 3. Now we'll be appending that node's value to level like this, and we will, if that is not null, because we have to also check yes, this node value is not null, not none, and we will check the left and right, and if it is there we will append it to the queue. So the left and right are 9. 9 will be going first because we are calling it first, and 20. So now this part of the code is done. We will get out of the loop because this was only going to run one time. And now we'll check if the level exists. If the level is not null, yes, the level is exist, then we will append it to our list like this. Okay, so now the queue is not none. We will again continue and reset our level. We have level is now holding nothing, and now the length of queue is 2. Now we'll pop from the very left, meaning the very first element like 9, and we will check if it is not none like this. You can say we have to update here too. If node is currently holding 9, so we will append it to the level which we have already done. Now we will check its left and right. No, it does not have its own left and right, as you can see here. So what is going to happen is this loop will again continue because this loop was going to run 2 times. The length of the queue was 2. We will pop again from the stack, from the queue, not stack, this is queue. So queue is now empty. Now we are holding 20 as our node variable, and we will append it also to the list. We will check its left and right. Yes, 20 has its left and right. 15 and 5, 15 and 7, we will append them respectively, 15 and 7 left and right. And after doing this, we will just check if the level is not, if the level is existing, if the level is not empty, you can say, we will append it to our result. Okay, this is done now. Oh, why I did that? I was going to remove the inner elements. Yes. Okay, so now the loop will again continue because the queue is not null. So the level is resetted, and now the length of the queue is still 2. First it will check, we will pop 15 because the 15 was on the very first, on the very left, you can say, and append, check if it is you can say if it is none. It is not none, is it does hold a pointer. So we will add its value 15, and after that we will check if 15 have its own left and right. 15 does not have its own left and right. Loop will again continue, and now we will be popping 7 out of from the stack, not stack, queue, this is queue, and node will be 7. We will be appending it to the level, and we will check if 7 has its own left and right. 7 does not have its own left and right, so we will break it out of the loop, and because the loop was only going to run 2 times, and we will check if the level is not null, is not empty. We will append it to result. We will append this whole here like this, 15 and 7, and queue is empty. We will exit our loop, and we will just return our result. What was our result? Our result was this: 3 9 20 15 7, 3 9 20 15 7, and that's it.